Okay, so the next key concept is that renal regulation is a long-term mechanism for controlling acid-base balance. So, like I mentioned before, the body mostly produces hydrogen ions. That's what we do most often, which is why acidosis is more likely. So what we tend to do is we tend to secrete hydrogen ions through our urinary system. So those are the things that we are eliminating or getting rid of and putting into the filtrate so that it becomes urine and we get rid of it out of our bodies. So we tend to secrete hydrogen ions and we tend to reabsorb bicarbonate ions. So we are holding on to bicarbonate, getting rid of hydrogen ions because we usually have an excess of hydrogen ions and not so much for bicarbonate. And so the kidney tubules indirectly reabsorb bicarbonate from the filtrate and manufacture new bicarbonate within the tubule cells. And I'll show you how that works. Um, so and a couple of things that we do, we either secrete the hydrogen ions by itself directly or with ammonia. So we said that ammonia can act as a base as well. And so sometimes we get rid of hydrogen ions with ammonia. Ammonia combines with a hydrogen ion to make an ammonium ion, NH4+, and then we get rid of that in our filtrate, which is getting rid of a hydrogen ion in the process. And so too much hydrogen ions, whenever we have too much hydrogen ions, we get rid of it in our urine through secretion, and then we reabsorb more bicarbonate. This is what's going to happen most often. If we have too little hydrogen ions, though, if something occurs and our pH is too high and we have too little hydrogen ions, then what we'll do is the opposite. We'll reabsorb more of those hydrogen ions and we'll secrete out the bicarbonate in the urine. But generally, the body is constantly producing acids and therefore constantly producing hydrogen ions. And so it must secrete those hydrogen ions or get rid of them and reabsorb bicarbonate ions in order to prevent acidosis, because acidosis is more likely to occur. So this is how we do it. CO2, and you are already familiar with this equation. This is just showing you how this happens in the kidneys. So CO2 and water are combined. Let me switch to black. CO2 and water are combined. And then the CO2 and water combine with the help of carbonic anhydrase to make carbonic acid. But because the carbonic acid is an acid and there is fluid inside the cell, it is going to quickly dissociate or split, forming a hydrogen ion and a bicarbonate ion. And then the next step is that hydrogen ions are secreted into the filtrate. So we get rid of those because, again, we produce much more of those. So we get rid of it into the tubule. And then for each hydrogen ion that we secrete towards the filtrate, a bicarbonate ion is going to be reabsorbed. So the hydrogen ions are being put into the filtrate so that we excrete it out with our urine, while the bicarbonate is being reabsorbed into the blood. And I don't need you to know about the symports and antiports and how they get transported, but we did already talk about how many times these bicarbonates are, or these sodiums we said before, are usually moved in one direction with chloride in order to balance. But again, the biggest important thing here to note is that we are secreting hydrogen ions into the urine while we are reabsorbing bicarbonate into the blood. So bicarbonate to the blood, reabsorption, hydrogen into the filtrate, secretion. So while we're in the tubule, secreted hydrogens combine with bicarbonate, and it's happening all in the tubule here where the filtrate is. But this hydrogen ion that we just secreted out, we're trying to get rid of, actually combines with bicarbonate here in the filtrate and makes carbonic acid. And then that carbonic acid is split into water and CO2. And then we can diffuse that CO2 back into the kidney tubule cells. And then we can start this whole thing over again. So we can get rid of more hydrogen ions. So we're constantly removing those free floating hydrogen ions. And so the bicarbonate ion is formed in the filtrate, dissociates to release CO2 and water. The CO2 diffuses into the tubule where it triggers further hydrogen ion secretion. So we're just going in this loop of constantly getting rid of any excess hydrogen ions by combining them with certain chemicals in order to make sure they're not free floating and decreasing our pH. Another way, and I already mentioned this, the way we get rid of hydrogen ions is by using ammonium. And so ammonia. So ammonia, where are we at? Here we go. So you have here our PCT cells metabolize what's called glutamine, which is an amino acid, I believe, to ammonium and bicarbonate. And so that ammonium has a hydrogen ion attached. And so the hydrogen ion on this ammonium gets secreted out to the filtrate, and we get rid of it through our urine while the bicarbonate is being reabsorbed. And now we have a new bicarbonate from this glutamine that we started off with. So the biggest picture here is to know that we are constantly getting rid of hydrogen ions while we are reabsorbing bicarbonate ions. And this is normal because we produce much more hydrogen ions than we do bicarbonate. So acidosis is always going to be more likely. So if alkalosis occurs, hydrogen ions are not going to be secreted. If we're in alkalosis and our pH is too high, we do not want to get rid of those hydrogen ions. That it's going to help us bring that pH back down. And then in that case, whenever aldosterone is triggered to reabsorb more sodium, we're actually going to bring in a chloride like we normally do instead of bringing in, or we're going to bring in a chloride instead of a bicarbonate ion. So again, in this, on this diagram that we showed in fluid balance 1, sodium is absorbed by the use of aldosterone and chloride follows. However, if we are in acidosis or if our pH is a little bit on the low side, we'll actually bring in a bicarbonate instead of a chloride. But if we're in alkalosis or our pH is a little bit too high, we'll bring in a chloride instead of a bicarbonate. So it all just depends on where our pH is at that time. I think I'm going to stop the recording here and then we'll move on to the last topic.